Welcome to Rges Geometry. This is section 1.3, Undefined Terms and Definitions. Please turn in your book to page 9 and read the aspects of a good definition and the example problem. This is very important, but I think you can read it on your own. The reason it is important is geometry, in particular, is a very precise form of mathematics, and it works a lot with definitions and building up very accurate definitions. So they want to set you on the right course by getting you attentive to the details of good definitions. So pay attention to that. The part that I really want to talk to you about, however, is what we call undefined terms. In geometry, there are really only 3 of them, and this goes all the way back to Euclid and his geometry. He said, while we have a good idea of what a point is, or a line is, or a plane is, it's very difficult to define these terms. And after you've read the first section and what's required for a good definition, you'll appreciate why. So, the 3 undefined terms in geometry are the point, the line, and the plane. And you definitely need to know this. Notice a point has no length or width. It has 0 dimensions. It is a concept of place or location. So we really can't represent it. It's a mental construct for us. We would represent it on paper or label it on paper with a dot and a capital letter. A line has 1 dimension. It only has length. It does not have width. We'll write it with this symbol here, with the arrows in both sides of the line segment, indicating that a line goes on forever and ever. Again, a mental construct, something we could not actually draw. We could label that line 2 ways: by identifying 2 points on the line, A and B, or in which case the symbol would be AB with a arrow in both directions. Sorry, that didn't come out very well. Or we sometimes, without paying attention to a point on the line, will sometimes just label a line with a small letter. That would be a L, for instance. So this would be line L. Finally, a plane has 2 dimensions. It goes on and on, both in length and width. You could think of the ceiling or the wall of a room as somewhat of a picture of a line, and where the ceiling and the wall meets would be the line, and the ceiling itself or the wall itself would be the plane. But really, that's a poor visual because those stop at some point. But a plane goes on and on in both directions. We'll draw a plane in a geometry class like that. It could be drawn, doesn't matter which direction I do it, and I will label it with a small letter, in this case a K. In geometry, you do care when it is appropriate to use capital letters and when it is appropriate to use small letters. So do the best you can on the assigned work. We will discuss any ideas in class. And the last thing I'd like you to do is do the cumulative review. Why don't you go ahead and pause right now, turn to page 13 in your book, and do the cumulative review, numbers 25 through 29 all, first off. You could put that first in your homework set, and then check those answers with me on this tape when you are finished. The reason I'm doing that is because you only have odd answers, and I want to make sure you know all of these answers. For number 25, it says A is the set 1, 3, and 5. B is the set of elements X such that X is an odd integer. Well, when we think of the relationship between these two sets, we see that A is a subset of B, but that is not our most specific relationship. A, in fact, is a proper subset of B, which means it is a subset of B, but not identical to B, really less elements than B. Okay, number 26. 26 says A is an element X such that X is a prime number greater than 2. Well, what's a prime number greater than 2? Well, 3, not 4, that's not prime. 5, 6 is not prime. 7 is prime. 8 is not prime. 9 is not prime. 10 is not prime. 11 is prime. 13 is prime. We can go on and on. B is the elements X such that X is an even integer. Are any of these even? No. Could any of these ever be even as I keep going in this direction? No, because it would be divisible by 2. And remember, a prime number only is divisible by 1 in itself. So these two sets have nothing in common. They are disjoint, if you recall that term. So I would say A, the intersection of set A and set B is the null set. Number 27. Number 27 says A is the set with the elements X such that X is the square of an integer. Well, let's see, we have the integer 0 and its square is 0, the integer 1, its square is 1, the integer 2, its square is 4, the integer 3, its square is 9. You see what I'm doing? I'm thinking, what would the elements of set A look like? Set B is listing the elements, and what are they? 0, 1, 4, 9, etc. And as I go 16, 25, I do recognize that these are the exact same set of elements in both. And so if you have the same set of elements in both, set A equals set B. In 28, A has a list of elements, 1, 11, 21, 31. B has a list of elements also, negative 11, 1, 11, 121, 1331. Well, we notice that they certainly are not the same, and they're not even equivalent because there's a different number of elements in each, but we do have some they share. Which ones do they share? Well, they share the elements 1 and 11. So these two are intersecting. And so A does intersect B, composing the elements 1 and 11. And finally, number 29. A is the list of elements X such that X is greater than 2. B is the list of elements X such that X is less than or equal to 2. Well, we notice that these two groups are mutually exclusive. So we would say that A and B are complementary to one another, or I can write it as an equation this way: A equals the complement of B. I could also have written B equals the complement of A. So hopefully all those make sense to you, and go ahead and finish the rest of your homework and correct your work for that.